Oh yeah, this is the second half of the review, Test D Part 2. Put your pencils down. Do not copy off me. If you need this video, watch it, learn it, go back, do the problems your own self. Don't be a fool. Okay, problem number 1. Okay, so these are the compound interest problems. Compound interest. Continuously, monthly. This is 2 different formulas. Formulas, which by the way, you will not be given. So there's that. Here are the 2 compound interest formulas. Well, here's the first one. N represents the number of times a year that you compound. So this is going to be the one we use when we're given a certain number of times a year that you're compounding. So if I say compounded semi-annually, N is 2. If I say compounded quarterly, N is 4. If I say compounded monthly, N is 12. If I say compounded daily, N is 365. So if you're given an N value like that, then this is the formula that you would use. Now, if I say compounded continuously, that doesn't give you any N value. Alright, that's all the time. There's no N value there. That's infinity. So you need something else. Turns out that if you're compounding continuously, the PERT formula will model that situation for you. E being a constant that is very close to 2.72. Okay, so these are the 2 formulas. Looking back, so this first one says continuously. So just get set up over here. So we're definitely going to rock the PERT formula for this one. So y is equal to p e to the RT power. Now, this $12,000, if it's the initial amount, it's going to go for the p. If it's the eventual amount that we'll have years later, it will go in for y. But it says you deposit $12,000 into an account that earns this much interest. Find the balance after 10 years. Alright, that means this is the initial amount, so it's going to go for p. So this will become y equals 12,000 e to the, now r is the rate written as a decimal. Okay, you've got to move the decimal 2 times to the left to make this percent into a decimal. 1, 2. Alright, so that's why I'm going to need a 0 here. So this is going to be 0.098. Okay, that's going to be my R value. That's my rate. Okay, so that's why I'm going to put 0.098. And then we have the T. Find the balance after 10 years. So T is 10 because of the 10 years. Alright, don't be fooled because it says annual interest. Okay, it's not going to be 1. It's 10 years. Alright, it always says annual interest. That's just how they calculate interest. Anyway, if you are not allowed to use a TI-30XS multi-view, then as far as the test goes, you'll be simply asked to show what you would have typed into your calculator, in which case you could just write down this right here, and that would be your answer. But since we're not taking the test right this second, let's go ahead and follow through and see what it looks like. You know what I'm saying? Let's check it out. Okay, let's quit this mess. So 12,000. Alright, see the E right there? So E to the 0.098 times 10. And there it is. So 10 years later, we will have $31,973. 47 cents. Okay, so if you were allowed to use a TI-30XS multi-view, then this would be the answer. If not, then you'd have to just give me the setup. Alright, anyway, monthly, that's when we use this formula where we're given an n value. In this case, n is 12. Monthly. Okay, yeah, you get it. So, the formula is y equals p times 1 plus r over n to the nt power. So this is still the p, so that doesn't change. So this is going to be y equals 12,000 times 1 plus, the rate is still this 0. I like this 0. Yeah, I messed it up. I said the rate is still 0.098 over an n. It's monthly, so that's 12. Okay, and then the n is 12 again. And, you know, it's still 10 years, so t is still 10. Okay? So, if you do not have a TI-30XS multi-view, meaning if you're taking the test, then you would just put a box around this. Just give me all this and stop. But we have the calculator, so, you know, let's get her done. So, let's see. So, that's going to be 12,000 times 1 plus fraction mode 0.098 over 12, close the parentheses, to the 12 times 10 power. Okay, $31,846. And 47 cents. Ha! It's funny that's the exact same amount of cents. Coincidence. You gotta love it. So this is the answer. Notice you get a little bit more money compounding continuously versus monthly, but they should be pretty close to each other. If you get two completely different numbers, you know, like 31,000 and 15,000, you did something wrong. Okay, that's it for number 1. Number 2, write a logarithmic function that has been reflected over the x-axis. Okay, starting with the you know, a parent function, which would be like log x. Let's just start with that. Reflecting over the x-axis, a negative sign will do that. Vertical asymptote of 5. Well, look, you know that normally a log function has a vertical asymptote on the y-axis, like this. Bam. So if you're coming up with an asymptote that's at 5, like over here, okay, then that means that mess was shifted over to the right by 5. So, what kind of a change would cause me to be shifted to the right by 5? Well, that's an inside the parentheses type of a change. This is where your left-right motion happens. So you must have parentheses, by the way. Let's see. So to the right is the opposite of what you would think. So we'd need a minus 5 to move us to the right by 5. So kabam. That's it. That's the answer. Notice if you didn't have the parentheses, if you just had log x minus 5 like this, then this minus 5 would be, this would mean down 5. Okay, with parentheses, it means right 5. Okay, so be careful. Number 3, similarly, write a function that has been shifted down 8 units. So, okay, here we go. Once again, starting with the parent function, which could just be log x, down 8 units. So that means we need like a minus 8 on the end, no parentheses, and vertically stretched by a factor of 4. Well, if I multiply by 4, then there's your vertical stretched by a factor of 4. That's it. Very simple. Okay. Number 5 and 6. Graph each function, blah, blah, blah. Okay. So we're going to do what we do, ladies and gentlemen. So let us start out. Let me get my green going. I'm going to zoom in a little. Now, when we graph these log functions, we start with the y value. So -2, -1, 0, 1, and 2. We always start off like this. Next, considering the parent function is y equals log base 1/2 of x. All right, that's the parent function. It will be useful to rewrite this in exponent form. So starting with the base of 1/2. Okay, then I've got this base of 1/2. Now this y and x change sides, right? So the x is going to wind up over here, and the y is going to wind up over here as the exponent. So this is how I'm going to find the x's, because my x's will be 1/2 to the y power. Okay, so that means I'm doing 1/2 to the -2 power, and 1/2 to the -1 power, and 1/2 to the 0 power, and 1/2 to the 1 power, and 1/2 to the 2nd power. Please remember that this will be the reciprocal. Okay, this will be the same thing as 2 squared. All right, negative power, you do the reciprocal and make it positive. Of course, 2 squared is 4, so there you go. Kabam. Reciprocal, that'll be 2. Anything to the 0 power is 1. Anything to the 1 power is itself. If I square this, I will get 1/4. So there you go. Do we have an a value this time? Yeah, we do. The a value is 2. So that means to get from here to here, I'm going to multiply everything by 2. So that's going to make this -4 and -2 and 0 and 2 and 4. Alright, I'm multiplying all my y values by 2. Okay, so we can go ahead and cross this out. So these will be the values that we will graph. They will be temporary though, so we will not connect them. Alright, Demetrius, do not connect these points. Alright, just put them down, do not connect them. So I've got 4, -4. So here I've got 4, -4, 2, -2. Okay, that's nice. 1, 0. I've got 1/2, 2, so that's over half a square, and up 2. And then 1/4 of a square and up 4. So just a little bit, and it'll be like right here. So we all see what's happening. It's curving in towards our asymptote, but do not draw it. Now the last step is to do any shifting that's happening, translations, if you will. So this -3, all right, is this up, down, left, or right? Well, this is not in parentheses. Okay, so this is just hanging on the end. So this is a down 3 situation. Down 3. So I'm going to take all these points and simply move them down 3. So this one is going to drop down and be here. Okay, this one will be here. This one here. This one here. Every point is getting dropped down 3. So this one will be here. So the blue points are the final answers. Okay? Alright, so now we can draw the curve. The asymptote. Did the asymptote change, or is it still the y-axis? Well, moving down or up does not change a vertical line. It goes forever. So the asymptote is the same. Let's draw it as a dotted line. Alright, so there's the asymptote. Now focus your eyes on the blue, because that is the curve that we're about to draw. Okay, You can tell this getting closer and closer to the asymptote. It's already almost seeming to touch by the time we get here. So since we need to go all the way to the edge, this part of the graph is just going to appear to trace along the asymptote. Unavoidable. Not doing a great job, but whatever. Okay, and then it branches out. Just do your very best. Okay, make sure your graph goes all the way to the edges of the grid. So it should look something very much like this. So that's it. That's your final answer. We're done. We're done with number 5. Okay, number 6, same type thing. Once again, the y values will be -2, -1, 0, 1, and 2. Alright, the x values, once again, let me make this a little smaller. It's useful to think of this as y equals log base 3 of x. Alright, that's the parent function. Alright, I'm ignoring the shifting for now. If I write this as the inverse, not the inverse, if I write this in exponent form, starting with the base of 3, the y and the x are going to trade sides. So I'll have the x over here, and the y is going to come over to the right and become this power. This is how I will find my x values, because the x values will be 3 to the y power. That means I will have 3 to the -2 power, and 3 to the -1 power, and 3 to the 0, and 3 to the 1, and 3 to the 2. This will drop you down, so I will have 1/9, and 1/3, and 1, and 3, and 9. Okay? Now, is there an a value? No, there's no a value here. So we can just forget about the third column, just cross it out. So we will go ahead and graph these, but this is not the final answer, so do not connect these dots. So 1/9 and -2. 1/9 of a square is almost microscopic, so 1/9 is going to appear to be on the line, so it'll be like there, 1/9 of a square and -2. Now 1/3 of a square is at -1, alright? That should be over visibly, alright, to the right and at -1. Now I get to go a whole square over and up 0. And then 3, 1, and 9, 2. Okay, those are the skeleton, the parent function. Leave them, don't skip this. Alright, you must show the dots. That's mandatory. Now we will do the shifting, and that will give us the final answer. Alright, this part here is a translation that is left 3. Alright, inside the parentheses, this is always your left-right motion, and this is always the opposite of what it looks. So positive is actually to the left. This part here is going to be a shift of up 1, a translation of up 1. So left 3, up 1. Okay? So starting with this guy right here, if I go left 3 and up 1, it's going to be right here. Alright, this one, same thing, it's going to be right here. Okay, and then this one will be here, and this one will be here. Okay, and left 3 up 1 will be here. Alright, so these are the 5 points that we're going to use. Now, the asymptote. Is the asymptote still going to be the y-axis? No, because of the shift left 3. Alright, left-right motions affect the asymptote. So the asymptote will be over here, left 3. Draw it. Don't skip that part. Alright, so there's the asymptote. Alright, there's a point right there. So we will go ahead and draw this curve as best we can. It's already appearing to touch the asymptote right here, so certainly by the time we get down here, it's going to be so close to the asymptote that as far as we can tell, it looks like it's touching. even though we know that's not. Alright, whoa, messed that up a little bit. Okay, I'm just going to do my best. Okay, so your graph should look very much like that. Make sure your graph goes all the way to the edge of the grid. Do not let it stop short, or I will mark it wrong, I assure you. Okay, so that's it. That's the final answer for number 6. Okay, beautiful. All right, now problem number 7 refers back to problem number 6, domain and range. Remember, your domain is how far the graph goes from left to right. It's the x values. So to the left, we're hitting a brick wall over here at -3. Doesn't go past it. It's the asymptote. So the domain will be -3 to infinity, left to right. Alright, make sure you use a round parenthesis to show that the -3 itself is not included in the domain. Alright, even though it looks like it, the function never touches the asymptote, never reaches it. Next, we're supposed to do the range. Now, the range is how far the graph reaches from bottom to top. It's the y values. Now, this graph goes down forever, and it drifts up forever. So that's -infinity to +infinity for the range. It has to be in that order. It's always bottom to top. Alright, it's always least to greatest, by the way. And that goes for domain and range. It's always least to greatest. Alright, that just leaves the asymptote, which we know is at -3. If you just put -3 though, I will mark it wrong. Okay, this is x equals -3, vertical line. If it's horizontal, that would have been y equals. Alright, but log functions have the vertical. Okay, is this increasing or decreasing? Okay, now so you have to read it from left to right. So as I go from left to right, I'm going up, 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 up. So that's increasing. Alright, that's number 7. So, next page, number 8. Inverse. Yeah, buddy. Let's talk inverse right now. Okay, so this is basically y equals all of this. So the first step of finding the inverse is to switch the places of the x and the y. Alright? Hey, if you have a pencil in your hand, put it down. Do not copy off of me. Alright? Watch the video and then go back and do it yourself. You have to show every step. Okay? I'm talking to you, Evan. Show every step of this process, okay? So if we switch the x and the y, this will become x equals log base 11 of y plus 7. Alright, you have to show this. No step that I'm doing is optional. Now I can go ahead and rewrite this in exponent form. Starting with the base, 11. Alright, now in exponent form there will be no log, no log. But these two quantities will change sides. So the y plus 7 is going to end up out here, and the x will end up over here as the power. So we will have our answer when we get y by itself. So go ahead and show this, subtracting 7 from both sides. So our final answer is going to be f inverse, instead of y, let's put the f back in there, is equal to 11 to the x power minus 7. Okay? It cannot be magic. I need to see all 3 of these steps. Alright, similarly, number 9. Notice how this does not have log in it. That's because this is in exponent form. So you can bet that by the end, it's going to become log form. Now, this is y equals, basically. So first we switch the x and the y. So this will become x equals 5 times 8 to the y power minus 7. So now it's all about getting y by itself. Now we cannot switch to any other form until we have this part, the base and power, by itself. So we're going to have to get rid of the negative 7 and the 5. Start with the negative 7. Show this step, alright? Adding 7 to both sides. These cancel out. So then we will have x plus 7 is equal to 5 times 8 to the y power. Alright? Still have to get this by itself. So we got to get rid of that 5. So we will divide both sides by 5 now. Okay, that way these will cancel. That's going to finally put this by itself. Okay, so now I have x plus 7 over 5 is equal to 8 to the y power. Now that this base and power is alone, I can rewrite this in log form. Starting with the base. The base is 8. Now in log form, of course, I will have to write log. Log base 8. Now, look, let me emphasize the following. Pay attention. You have to be careful how you write this, or we'll have to mark it wrong. Alright, imagine this invisible line that's right here. Like it's on, well, on your, if there were notebook paper, it would be lines on your notebook paper. This 8 is going to become the base, alright? This is log base 8. So because of that, this 8 should be hanging low, should be below the line, like this. Okay? Now, these two things are going to switch sides. Okay, so the y is going to come out here, and this is going to come over here. So I'm going to have my x plus 7 over 5 should be on the line. Okay? This is not, don't do this, alright? I see kids do stuff like this all the time. They put the 8 way up here, like right with the LOG, and then they want to put the x plus 7 over 5 like up high, like it's a power. If I see this, I'm going to mark it wrong. Okay, this is not a base if you do with that. This is like an invisible base 10. Don't do it. Okay, that 8 has to be hanging low. Anyway, that's the answer. That's it. We will go ahead and put our g back in there. So we will say g in, I'm just going to erase it. G inverse. And that's your answer. Okay, number 10. Same thing. This is like having y equals. So reverse your x and your y. So this will become x equals natural log y minus 9 plus 5. Now this has the log in it, the natural log. So we will wind up using exponent form later. But first we have to get the log part by itself. So this has to be by itself before I change the form. So of course I'm going to subtract 5 from both sides. So that'll give me x minus 5 is equal to natural log y minus 9. Now that this is by itself, I can write it in exponent form. Now please understand that there's an invisible base e right here because it's natural log. So when I do my exponent form, I'm going to start with this base e. Alright, now this x minus 5 and this y minus 9 are going to switch sides. So I'm going to have y minus 9 out front, and this x minus 5 is going to come and be the power, exponent. Okay, so then I just need to get y by itself, so I'm going to add 9 to both sides. Okay, let's put the h back now. So that's going to give me h inverse is equal to all of this. So it's going to be e to the x minus 5 power plus 9. Okay, that's the answer for number 10. Number 11. Don't forget about the invisible base 10. So first of all, this is like having a y. So we will start by switching the x and the y. So I will have x equals log y minus 6. Now we need to solve for y. Ultimately, we will write this in exponent form. But before we can do that, we need to get the log part by itself. Notice I did not include the 6. Okay, let me see a similar problem. Yeah, like over here, when I looked at the log term, I looked at the entire, including the minus 9. That's because the minus 9 is in parentheses. Okay, this 6 is not in parentheses, so it's not part of the log expression. So it's got to go. So I'm going to do plus 6 on both sides. So that'll give me x plus 6 is equal to log y. Okay? Now that this is by itself, I can go ahead and rewrite this in exponent form. Understand that this is base 10. So when I rewrite it, I'm going to start with that base 10. So I'm going to have, okay, starting with my base 10. Now the y and the x plus 6 are going to change sides. So the y is going to come here, and the x plus 6 is going to end up in the exponent. Alright, and that's it. This is a y is by itself, so my answer will be p inverse is equal to 10 to the x plus 6 power. Alright, that is number 11. Okay, now we're going to have to do a double graph. We need to graph the following log function and its inverse on the same coordinate plane. Alright, the original and the inverse. Okay, if you have a pencil in your hand, for goodness sake, put it down. You can copy me all day long, and that's not going to help you learn anything. Alright, watch me do it. Go back and do it yourself from the beginning. And that's the only way you're going to see if you know how to do this or not. So put your pencil down immediately. Okay. Well, now the first part we've already practiced, graphing the log function. Alright, we've done that twice already. Or maybe that was on the other video. No, we did it right here. It was on this video. Okay. Anyway, so we're experts at this. So we're going to start out with the y values here. Alright, so we're going to start off with -2, -1, 0, 1, and 2. Okay. We are going to start off with the parent function, which is y equals log base 3 of x. If we go ahead and rewrite this in exponent form, alright, always start with the base, which is 3. The y and the x will switch sides, so that'll give me x equals 3 to the y power. That's how I'm going to get these x's, because that means I'm going to do 3 to the -2 power, 3 to the -1 power, 3 to the 0 power, 3 to the 1, and 3 to the 2. That's how I will get these x's. Don't forget the -2 drops you down to the denominator, so I'll have 1/9 and 1/3. Anything to the 0 power is 1, and then I have 3 and 9. So this is what I have so far. Is there an a value? Well, yes. The a value is -1. This negative sign is a -1. So to get from here to here, I'm going to have to multiply everything times -1. So basically everything will just change signs. So this will become +2, +1, 0, -1, and -2. When you have that third column, you can just forget about the middle column. Alright, forget it ever existed. So let's go ahead and graph these, but these will be temporary because we haven't done the shifting yet. Alright, and I always do these temporary ones in green. So 1/9, comma 2. So 1/9 is almost nothing. So it's just going to be right here on the line. I mean, it's not really on the line, but almost. 1/3, comma 1. So over just a little bit and up 1, like here. 1, comma 0, 3, comma -1, and 9, comma -2 will be right here. Okay, do not connect these, Demetrius, or anybody. Okay, now it's time for the shifting. Alright, now these will be the actual points of the final answer, so I'll do it in blue. This is going to cause a shift of left 3. In fact, let me make a little table here. So the original, okay, the original has to be shifted left 3, and this +1 right here is going to shift us up 1. Okay, later we'll wind up talking about what happens with the shifting of the inverse. Okay, we'll deal with that in a minute. But for right now, let's shift everything left 3 and up 1. And these ones we will connect. So, starting with this one, left 3, up 1 will be right here. Okay, left 3, up 1 will be right here. Alright, left 3, up 1, left 3, up 1, and finally left 3, up 1. Where's the asymptote? Well, remember that left 3 part? That's the asymptote is shifting left 3 as well. So there's the asymptote, and focus on the blue dots because that's the real deal. Alright, so this is going to come approaching the asymptote. So by the time we get up here, it's going to appear to be tracing the asymptote. So it gets down here and starts curving on away. So your graph should look something like that. Alright, not the best job there, but what are you going to do? So this blue represents the original graph. Once you finish with the original graph, it's time to start working on the inverse. Now, for the inverse, which will wind up being an exponential function, by the way, focus on this table of values, except for the x's and y's will be reversed. So when I look at this, I'm going to think 2, 1/9. Everything has to be reversed. And so let's graph those. Now these are temporary, so we will not connect them, but 2, 1/9, that's over 2 and up pretty much nothing. Alright, 1/9 is really small. And then this one, alright, will be like having 1, 1/3. So over 1, up a little bit. So that'll be like right about there. And then this one will be 0, 1 once you switch them. So 0, 1 would be right here. And then this would be -1, 3. So -1, 3 would be right here. And then this one would be -2, 9 once you reverse them. So -2, 9 would be right here. Alright, so these orange dots are the temporary skeleton of the inverse. So the only thing that's left to worry about is how will we shift it to get the final answer. And look, you got to be really careful because it's not going to be shifted the same way as the original was. So here's how you understand how the inverse will shift. First of all, these numbers won't change, so it's still going to be 3 and 1. But here's what you have to understand. All right, this is the part that just blows your mind. Like, what is he talking about? If you picture a graph, you know, like a XY graph, you understand that this is the positive side, left, right, and this is the positive side of up, down. Down here, this is negative and negative. Okay? Now, the words that go with these, like this is right, and this is up, and this is left, and this is down. Okay, what happens is when you do the inverse, any shift that was up will become right, and vice versa. Anything that was right will become up. So basically the two positive words switch places. And similarly, the two negative words will switch places. So anything that was a left shift for the original graph will become a downshift for the inverse, and vice versa. So anything that would be a downshift for the original will become a left shift for the inverse. Okay, so the two positive words switch, and the two negative words switch. Okay, so for the original we had left and up. Okay, left is a negative word. Alright, it's negative. So when we do the inverse, it's going to be the other negative word. So instead of left, it will be down. Okay, because that's the other negative word. They switch with each other. Now up is a positive word. So for the inverse, it's going to be the other positive word. And the other positive word is right. So it will be down 3, right 1. Okay? So we will take each one of these orange points and shift them down 3, right 1. So down 3, right 1 will be here. Down 3, right 1 will be right on there. Okay, down 3, right 1. Okay, there's that one. Okay, so down 1, 2, 3, right 1 will be here. And down 3, right 1 will be here. So these red dots will be the final answer for the inverse. Now, the asymptote. The log function has a vertical asymptote. The inverse will have a horizontal asymptote. Alright, now it'll be at the same number though. So the vertical asymptote is at -3. So guess what? The horizontal asymptote will also be at -3. Alright, by this time this graph is getting pretty messy, and that's why I do this in colors to help me see and focus my eyes. So I really recommend that you use colors as well. Otherwise, like imagine if you are doing this all in pencil, then look at all these dots, man. You're gonna get confused. So use colors if you can. At least use a pen and a pencil. Okay, use like a pencil for the original and then a pen for the inverse, something like that. Anyway, focus on the red. Alright, ignore all the other dots, just the red. So clearly the red is coming down like this, and it's coming to the asymptote, which is here. So we will draw it like this. Okay. Notice that this image, they're mirror images of each other diagonally. Okay. And this is a way to easily check your answers when you graph these things. This diagonal line is the line called y equals x. And the blue and the red should be mirror images of each other over this diagonal line y equals x. So you can see this tail matches this blue tail, and this blue curve over here It's exactly identical to this blue curve over here. Okay? But that's the line y equals x is not part of your answer, so don't draw it. Just imagine it. All right, well that is it. That is how you do a function and its inverse on the same graph. Okay, now let's do end behavior and everything for the original graph and the inverse. So for the original graph, end behavior, so the blue. Okay, on the left, you know, back in the day, it often used to be as x approaches negative infinity. But look, brick wall, hello, asymptote, it doesn't approach negative infinity. It approaches -3. It approaches the asymptote on the left. So the left end behavior will start off like this. As x approaches -3. So we've said what's happening to the x values. Now we say what's happening to the y values, f of x. So as we go towards -3, the y values go up, 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 up. Why did I put equals? I don't know. I meant to put approaches. So because as we go towards -3, it goes up, 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 that is positive infinity. Okay? Now, the right end behavior does go to infinity. So as x approaches positive infinity, all right, that's what happens to the x values. What happens to the y values? So as I go to the right, it goes down, 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 down. So that'll be negative infinity. There, do not get distracted by this asymptote down here and think, oh, but it's going to stop at -3. No. The green asymptote is the original. All right? This orange, this is the asymptote of the inverse. It has no effect on the original graph. Okay, let's switch over and do the end behavior of the inverse graph. Okay, so now we're looking at the red. Focus on the red. So on the left, as we go to the left, it does go to the left forever. So we will say as x approaches negative infinity. So that's the x values. What happens to the y values? Okay, as we go to the left, it goes up, 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 up. So that's positive infinity. Now we'll do the right end behavior. So as x approaches positive infinity, what happens to the y values? So looking at the red, so as we go to the right, all right, I'm going to the right, but as I go to the right, it goes down, down, whoa, it doesn't go down forever though, does it? It flattens out and approaches this asymptote. It approaches -3. So as we go to the right forever, the function approaches a y value of -3. Alright, now notice the similarities between the original and the inverse. Okay, can you see that these are very similar, only backwards? And these are very similar, only backwards, right? Positive, negative, negative, positive. -3, infinity, infinity, -3. If you note those patterns, it will help you check your answer, because if those patterns aren't forming, you did something wrong. Okay, as far as the X-Intercept, alright, well this was kind of an easy one because the X-Intercept is exactly at 0. So if it's ever between the lines, then you'll just have to estimate with a decimal. But this, hold on, I wanted to do it in blue. The X-Intercept is 0, 0. And look, the Y-Intercept happens to be the same thing. Alright, that's just a coincidence. 0, 0. Alright, the asymptote. Alright, for the inverse, the asymptote is horizontal, so that's y equals -3. Okay, for the original graph, it was vertical, so that's x equals -3. Alright, if you leave off the y or the x, it's wrong. Domain and range. Let's see, I got my blue marker out, so let's look at the blue. The domain is left to right, so -3 to infinity. Okay, the range is bottom to top, so this goes from -infinity to positive infinity. It doesn't stop here, right? It keeps going. So it goes from -infinity to positive infinity. Okay, now for the inverse, now we're looking at the red again. Domain is left to right. Okay, this goes left forever and right forever. So that's -infinity to positive infinity. Now the range, bottom to top, right? This time it has a floor here, bottom. So it has a bottom which starts as close as you want to get to -3. But then it goes up forever. So bottom to top, -3 to infinity. Now here again, notice the relationship. Domain is the same as the range of the inverse. The range of the original is the same as the domain. Alright, observe these patterns and make sure these patterns are happening every time you do the inverse. Alright, that way you'll catch a mistake. Okay, so that was the full and complete number 12. What else we got? Alright, I think we're getting to the end of this video. I think this is the last one. So, number 13. You need $45,000 in 13 years. How much should you invest now at 10.5% annual interest compounded daily? Round your answer to the nearest penny. Okay, first of all, you got to know which formula you're going to use. Are we going to use this one or this one? Well, it said daily, alright? This formula is only for continuously, not daily or quarterly or semi-annually or monthly. So it's got to be this one. If I say daily, what's n? 365, right? So, boom. Daily. Okay. So that means we're using this formula of y equals p times 1 plus r over n to the nt power. Now the question is this 45,000 going to go for p, or is it going to go here for y? So you got to read carefully because it depends. All right, the p here is the initial value. All right, that's now, and this y is like for the eventual amount years later. So is this the amount that we have now, or is this the amount that we're going to have years later? Well, it says if you need $45,000 in 13 years, that's 13 years from now. So this is not the original amount. So that's why it's going to go for the y value years later. Okay, so that's why we're going to start off with 45,000 equals, now p, we don't know what p is. It says how much should you invest now. Okay, that's your p value and we don't know it. So we have to leave that as a variable. So 1 plus. Now the rate, we know that. It says 10.5%. We need to change it to a decimal by moving this twice over. So that means the rate is going to be 0.105. Do not round this. Okay, so I've got 0.105 over n. Daily, n is 365. Okay, so n is still 365 times time. It says right here 13 years. So alright, it doesn't matter that it says annual interest. Okay, it's still compounded daily and still 13 years. So it is what it is. It always, anytime they give the interest, they give it as an annual rate. Okay, so we just have to solve this for p. Do not, I repeat, do not try to simplify this one piece at a time. Everything you do, you're going to wind up rounding, and I want the answer to the nearest penny. So no rounding allowed. Instead, what you have to do is to divide by all of this mess on both sides of the equation. So you're going to divide by 1 plus 0.105 over 365 to the 365 times 13 power. Divide by the whole thing. And over here too. Alright, because that way these will cancel out and just leave you with that p by itself. Okay, now here again, if this is on the test and you're not allowed to use a TI-30XS multi-view, then you would just put a box around this right here. You would just give me all of that. Just write it all down and put a box around it and call it your answer. But for now, we have a TI-30XS multi-view. So let's type it in. Okay, so we have 45,000 over 1 plus fraction mode 0.105 over 365, close your parentheses, to the 365 times 13 power. Okay, let's see if this does this make sense. So we're getting $11,494 and 39 cents. Okay, so that is the amount we would have to invest now, so that 13 years from now we will have $45,000. Alright, that's pretty cool, right? Alright, $11,500 turns into $45,000. That's a lot of increase if you can get an interest rate this good. And it is doable if you use the stock market and you're a little bit lucky. Okay, anyways, that's it. That was the last question. Please make sure you can do every problem on this sheet by yourself. All this stuff is on the test, guys. I will see you on the next video. Peace out.